Activity 5. Investigating y equals mx plus b. This is a part of Unit 2, Modeling Linear Relations. Example. Mark and Janet left Hamilton for a bike ride along the Bruce Trail to Brantford. Janet had a speedometer installed on her bike that measured both her speed and the distance traveled. She noticed that her speed and Mark's speed was constant throughout the entire trip. Their speed was 15 kilometers per hour. Create a table of values with time and distance as the variables. Here we have a table of values. We'll set up time in the left-hand column, in hours, and distance traveled in the right-hand column. For 0 hours, they'd have traveled 0 kilometers. For 1 hour, they'd have traveled 15 kilometers. For 2, they would travel 30. For 3, they would travel 45. And for 4, they would travel 60. Create a distance time graph to show Mark and Janet's bike ride. In a table of values, the independent variable is usually always in the left-hand column. So that will be our horizontal axes of our graph. So for our graph, we'll have time in hours in our horizontal axes and distance traveled in kilometers in our vertical axes. And we'll add a scale. We're going to let each square represent 1 hour along the bottom, and each square represent 10 kilometers along the vertical axes. Next, we'll plot our points. 0, 0 belongs right at the origin. 1 and 15, then 2 and 30, then 3 and 45, then 4 and 60. Now, since they didn't just instantly teleport every hour, they actually traveled through that whole time, we can connect the points with a straight line. How many kilometers would Mark and Janet ride in X hours? The answer to this question is taken by looking at the relationship between time and distance. We learned a little bit about rates of change. Speed is the rate of change relationship between time and distance. So in X hours, they would travel 15 times X, or 15X kilometers. That's how far they'd ride. Example again. We still see the same graph with Mark and Janet and their table of values. But now, along the trip, Mark and Janet met up with two friends, Marty and Sasha, who live in Ancaster, 10 kilometers away from where Mark and Janet began their ride. With respect to the beginning of the trip in Hamilton, Marty and Sasha start their ride 10 kilometers into the journey. So, at 0 hours, the distance traveled from Hamilton for Marty and Sasha would be 10 kilometers. Create a table of values and a distance time graph to show Marty and Sasha's bike ride. Well, we already have a distance time graph set up and a table of values set up. Let's just add an extra column for Marty and Sasha. So for 0 hours, they're 10 kilometers away from Hamilton. And we'll plot that point. For 1 hour, they're 15 plus 10 kilometers away from Hamilton, or 25, because they're riding at the same speed. We'll plot that point. For 2 hours, they're 30 plus 10, or 40 kilometers away, and we'll plot that point. For 3 hours, they're 45 plus 10, or 55 kilometers away. For 4 hours, they're 60 plus 10, or 70 kilometers away. And now that we've plotted the points, we can connect them with a line. And we'll label our line Marty and Sasha. Now, how many kilometers would Marty and Sasha ride away from Hamilton in X hours? Well, since they're riding at the same rate as Mark and Janet, and they already have 10 kilometers on them, they're going to ride 15x plus 10 kilometers away. Therefore, they would ride 15x plus 10 kilometers in X hours. The equation which would represent Mark and Janet would be d is equal to 15t, or the distance they've traveled is 15 times the time. The equation which would represent Marnie and Sasha would be d is equal to 15t plus 10, or their distance is equal to 15 times the amount of time ridden plus 10 kilometers, because they started 10 kilometers away. Example continued. If Marnie and Sasha had decided not to join Mark and Janet on a bike ride, they would not have traveled any distance at all. With respect to Mark and Janet's starting location, Marnie and Sasha would therefore remain 10 kilometers from Hamilton. Create a table of values and a distance time graph to show Marnie and Sasha's bike ride. Well, again, we already have the graph and the table of values. Let's just add an extra column for Marnie and Sasha. And it's not really a bike ride as much as it is a stay home and watch television. At 0 hours, they've ridden 10 kilometers. Well, they haven't really ridden 10 kilometers. They started 10 kilometers away. So at 0 hours, they're 10 kilometers from Hamilton. We'll plot that point. At 1 hour, they're 10 kilometers away from Hamilton. We'll plot that point. At 2 hours, they're 10 kilometers away from Hamilton, which we'll plot. The same for 3 hours. And 4 hours. And in fact, X hours as well. So Marnie and Sasha staying at home is represented by the horizontal line at 10 kilometers away from Hamilton. How many kilometers would Marnie and Sasha travel in X hours? Well, if they don't go anywhere, they'll always be 10 kilometers away from Hamilton. So, of course, since they're not traveling at all, but the distance is measured from Hamilton, the distance is 10, and it doesn't depend at all on time. In this situation, Mark and Janet's ride is still modeled by the equation d equals 15t. But Marnie and Sasha's now is represented by d equals 10. Because it's not dependent on time, there's no need for a t variable in the equation. Example continued. How are Marnie and Sasha traveling if the representing graph is a vertical line? A graph like this. Well, the time stays the same at t equals 1, while the distance changes. Have you ever moved in this fashion, where time doesn't change, but you move positions? You might have daydreamed about it, but it's not very likely that you've done it. If we look at a table of values for this, we could have at time 1 hour, they could be 10 kilometers apart. At time 1 hour, they could be 25 kilometers away. At time 1 hour, they could be 80 kilometers away. At time 1 hour, they could be 245 kilometers away. And at time 1 hour, they could be 415 kilometers away. The question is, how can they actually be 415 kilometers away after 1 hour when we know after 1 hour they're already 80 kilometers away? Well, the answer is they've got to be time traveling. It looks like Marnie and Sasha have had access to a teleporter, which transports you from place to place instantaneously. So they've used the transporter to go to different places along the Bruce Trail, and they've even transported as far as 415 kilometers from their start. I realize this isn't very realistic, but in this situation, distance does not depend upon time. The equation of this line becomes x equals 1, since the graph extends from 1 on the x-axis. So at time 1 hour, they can be any distance away from Hamilton as they want. Sounds nice. The key ideas here. A straight line has the equation y equals mx plus b, where y represents the final quantity of the dependent variable, x represents the variable quantity, the independent variable, m represents the constant multiple in the relationship, which we refer to as the rate of change or slope, and b represents the constant, the y-intercept or the initial value of y when x equals 0. When we graph independent and dependent variables, a graph may look like this. In our previous example, the distance from Hamilton, was y. The time from the start was x. The traveling speed was our rate of change, m, which is represented by our rise over our run, how we calculate our slope. Rise over run in this situation is distance over time, so kilometers per hour. And the initial distance from Hamilton is b, our y-intercept, which we see on the graph where the line crosses the y-axis. Key ideas continued. A horizontal line has the equation y equals b. The initial value is always the same under all conditions. It means that the dependent variable does not depend on the independent variable, and it just remains constant. So, y equals b would be a horizontal line that intersects the y-axis at the value b. It has a slope of 0. And we say it has an equation of y equals b. A vertical line has the equation x equals a, where the independent variable does not change with the dependent variable. The values of x never change under all conditions. This leads us to a straight line, which intersects the horizontal axis, the x-axis, at the value a. We call it a slope of undefined because there's no run, and when you divide by 0, you end up with a math error, or something that's undefined. So a vertical line has the equation x equals a, and a slope that's undefined. Example 1. A salesman is paid $600 per week, plus 10% of his sales. Create a table of values showing his pay in a week where his sales might vary from $0 to $2,000. Give this example a shot and then come back to see if your work is the same as ours.